Hello everyone, once again I'm here to discuss about some numerical problem based on electric potential and potential difference. And now the first problem as it is given here, so within that it states that 16 joule of work must be done to move an electric charge equal to 5 coulomb from a point where the potential is plus 20 volt to another point where the potential is V volt. Find the value of V. Now question is, we have to find out the potential at this point, suppose this V, and another point where the potential is 20 volt. Now we have to do work done to bring a 5 coulomb plus 5 coulomb charge from 20 volt to V volt as 60 joule. That means the potential at this point must be greater than of this. Remember that. Therefore, V A minus VB equal to W by Q. This formula is known for us. Now VA means the final, this VB means plus 20 volts means minus 20 equal to W means 60 and charge is 5 coulomb. Therefore V minus 20 equal to 12. Therefore V equal to 32 volt. That's all. Very simple. Now let's come to the second point. What is the potential at the surface of an iron nucleus? The radius of the nucleus is 4.2 into 10 to the minus 15 meter, as it is a Fermi order. We all know these things. And the atomic number is 26. Now, atomic number is 26. Therefore, we can say E is 1.6 into 10 to the power minus 19 coulomb and N is nothing but 26, as the atomic number is 26. Therefore, charge Q equal to N into E, that is equal to 26 into 1.6 into 10 to the power minus 19 coulomb. This is the total charge. Of course, this charge is a positive charge. Now, the formula V potential is 1 by 4 pi epsilon naught Q by R. Radius is already given. This R is 4.2 into 10 to the power minus 15. Therefore, 1 by 4 pi epsilon naught 9 into 10 to the power 9 into Q is nothing but 26 into 1.6 into 10 to the power minus 19 by R means 4.2 into 10 to the power minus 15. I hope you can solve it. That's all. Now let's proceed for the next one. Question number 3, where the electric potential is 0. Means a combination is already given. Plus 3 into 10 to the power minus 8 coulomb and minus 2 into 10 to the power minus 8 coulomb. And the whole things, these two charges is separated by a distance of 15 centimeter. So let us assume the point is here P, and assume that this P point is situated at a distance of x. Therefore this distance must be 15 minus x. Now this 15 is in centimeter, means 0.15 minus x. Okay, so we thought that at a distance of x from the minus 2 coulomb of charge to into 10 to the minus 8 coulomb of charge, electric potential is 0. Therefore, let us assume this is A, this is B. Therefore, V P A equal to nothing but 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught Q means 3 into 10 to the power minus 8 by 0.15 minus x. This is VPA, and VPB equal to 1 by 4 pi epsilon naught into minus 2 into 10 to the power minus 8 by x. Now, according to this question, we can say this VPA plus VPB, that should be equal to 0, and it changed to 1 by 4 pi epsilon naught 3 into 10 to the power minus 8 by 0.15 minus x minus 1 by 4 pi epsilon naught 2 into 10 to the power minus 8 by x, that should be equal to 0, or we can write as 1 by 4 pi epsilon naught 3 into 10 to the power minus 8 by 0.15 minus x equal to 1 by 4 pi epsilon naught 2 into 10 to the power minus 8 by x. This 2 is cancel out to each other. 10 to the power minus 8, 10 to the power minus 8 is also cancel out to each other, and the remaining part 3 by 0.15 minus x equal to 2 by x. Now I hope you can solve it and you can find out the value of x. That's all. Okay. Now the next type of problem. Problem based on multiple charges. Now within this multiple charges we will do two types of shape actually. One is triangle and another is a square. Now within that we will discuss two types of problem for triangle as well as the square. The first one is, suppose a triangle is given, within that the combination is shown in figure q minus 4q and plus 2q, in which the value of q is suppose 1.6 into 10 to the power minus 19 coulomb, means the charge of an electron, just like a charge of an electron. Now the first question, it can be that how much work is required to dissociate, or how much energy is required to dissociate this system, means how much energy is required to break this system. Now for that we have to find out net work done, or we can say the total energy. Now for that q for q means we will get three type of potential. One, total work done will be work done in between AB plus work done in between BC and work done in between CA. Therefore work done in between AB we can write as 1 by 4 pi epsilon naught Q A Q B by AB plus 1 by 4 pi epsilon naught Q B Q C by BC plus 1 by 4 pi epsilon naught Q C Q A by CA. Now this distance is suppose A, and hence it can be written as 1 by 4 pi epsilon naught common within bracket QA QB by AB plus QB QC by BC plus QC QA by CA. As it's a scalar quantity work done, so there is no need to find out any vector or direction, anything. Simply you just do this. Now the value of QA QB is known, and the value of AB BC and CA is also known. Means here in this case we can write as 1 by 4 pi epsilon naught into 1 by AB, or simply we can say 1 by A within bracket QA QB. QA QB means QA, that is nothing but Q, into QB is minus 4Q, therefore minus 4Q you have to write, plus BC means minus 4Q into 2Q plus 2Q into Q. Therefore this total thing can be written as 1 by 4 pi epsilon naught into A within bracket minus 4q square minus 8q square plus 2q square, and hence it will be 1 by 4 pi epsilon naught into A into minus 8 12 2 means minus 10 q square. Okay, now you can put the value of q even the value of A, and you can find out the net things. That's all. Now another type of problem based on triangle only. Let us assume one is 2q charge and here is 3q charge, and the separation is suppose 6 meter. Suppose the value of q is again 1.6 into 10 to the power minus 19 coulomb. Okay, now A is a point which is on the equatorial line of this. Now one want to put a 2q charge at this point, then how much work is required to put this 2q charge at a point of A? How to solve this problem? Let us consider these things. Is suppose it will be better to think as 4 meter. This distance is 4 meter. So what will be this distance? Of course it will be 5 meter. Why? Because if we consider A, this one is B, this one is C, then AB equal to square root of this BO, suppose this point is O, BO square plus OA square. Now BO means 3, 3 square is a 9, and 4 square means a 16, 16 plus 9 is a 25, and square root of 25 means simply 5. Therefore AB will be 5, as well as this AC also will be 5 meter. Okay, now the question, main question, work done required to Q charge to put at point A. This is the question. Now how to solve these things? Very simple, sir. At first we will find out potential at a point of A due to B, as well as the potential at a point of A due to C. The net potential, whatever you will get, that potential into 2Q will give us the work done required to put this charge at a point of A. Okay, therefore potential V at a point of A due to B, VAB will be 1 by 4 pi epsilon naught Q, Q means 2Q by 5, and VAC equal to 1 by 4 pi epsilon naught 3Q by 5. Therefore net potential V will be VAB plus VAC, and which leads to 1 by 4 pi epsilon naught, as well as you can take common as a Q, Q by 4 pi epsilon naught within bracket 2 by 5 plus 3 by 5. So 5 is a LCM. So 5 means Q by 4 pi epsilon naught, as 2 by 5 plus 3 by 5 is a 5. So 2 plus 3 is 5, 5 cancel out, means Q by 4 pi epsilon naught only. Okay. Now work done. Therefore work done W equal to V into Q. That Q means whatever charge we want to put, and we want to put plus 2Q charge. Therefore Q by 4 pi epsilon naught into 2Q will give us the total work done required, and its unit will be joule, of course. Now Q by 4 pi epsilon naught, 1 by 4 pi epsilon naught means 9 into 10 to the power 9 into 2 into Q square. Q square means 1.6 into 10 to the power minus 19 whole square. That much. Now you can solve these things. I hope. Now we will proceed with the square. Now if we consider a square, Suppose within the square charge is already given and it is 1 meter. All the charges are 2q. So if anyone want to put a charge small q at the center O, then what will happen? If anyone want to put a charge q at this center, so you have to find out potential at this point first for all these plus 2q charges. Now let us assume A, B, C and this point is D. Now the potential at the point of O due to A, B, C and D will be same because all the charges are plus 2q and all are in equal distance. So as this distance is 1 meter, so this one will be A root 2, that is only root 2. Therefore this distance will be root 2 by 2. Okay, as it is a half of this. Therefore AO equal to BO equal to CO equal to DO equal to root 2 by 2, and hence potential V will be 1 by 4 pi epsilon naught. Q means actually it will be 2Q of 1 by AO plus 1 by OB plus 1 by OC plus 1 by OD means root 2, 1 by root 2 by 2 means 2 by root 2 plus 2 by root 2 plus 2 by root 2 plus 2 by root 2. Okay, now this one I hope you can solve. 2q by 4 pi epsilon naught, 4 pi epsilon naught into you can take common 2 into 1 by root 2 plus 1 by root 2 plus 1 by root 2 and plus 1 by root 2, and like this way you can solve it, means 2 into 4 by root 2. And if you just put the value of q and 1 by 4 pi epsilon naught, then you can find the value of this V at the point of O, and work done or the energy required to put this q charge at this point of O will be q into V. That's all. Okay. Now the next problem based on the square is, if the square does not contain any type of charge, and if one want to put charge at this point q, then this point again q, here is also q and here is also q, then how much work is required or how much work done is required or energy is required. Now for this type of case A, B, C, D, at each and every point we want to put a charge of q. At this case, at first when we put a charge at the point of A, at that time VA is 0 because there is no charge at all. Therefore work done W1 will be 0. But in case of B, if one want to put a charge Q at a point of B, beforehand you have already placed a charge of small q at a point of A. That means we'll get a potential at a point of B due to the charge A, means Q. Let us assume this distance is A. Therefore potential at a point of B will be 1 by 4 pi epsilon naught q by A, and work done W2 will be VB into this q, means actually it will be 1 by 4 pi epsilon naught q square by A. This is for VB. Now what about C? VC, now at this point if anyone want to put the charge, same charge q, so at this point he can find out a potential due to charge q, and here is also a charge of q, means Vc will be Vca plus Vcb. So Vcea will be 1 by 4 pi epsilon naught q by a root 2 plus 1 by 4 pi epsilon naught q by a, and work done W3 will be 1 by 4 pi epsilon naught q into q 1 by a root 2 plus 1 by a. This is W3. And what about W4? Means we have already placed a charge q here, and if one want to put another charge q here, means he have to find out work done, potential at a point of D due to A, B, C, and then he have to multiply it with a charge of q, means V D will be V D A plus V D B plus V D C, means simply one can write 1 by 4 pi epsilon naught q by A plus 1 by 4 pi epsilon naught q by a root 2 plus 1 by 4 pi epsilon naught q by a, and work done W4 will be 1 by 4 pi epsilon naught q into q within bracket 1 by a plus 1 by a root 2 plus 1 by a, and total work done W will be W1 plus W2 plus W3 plus W4, and we know this value of W1, W2, W3, W4. We'll just put it and we will get the answer. That's all about this. So this type of problem you will get. I will send you this type of problem, some of the question in your WhatsApp. So we'll meet once again with some new theory, means electric potential for different things, equipotential surface, even the properties of equipotential surface, etc. So see you next video. Thank you. Have a great day.